Hi guys, my name is Vivek and in this video we will continue to talk about materialized views in Oracle. Guys, if you have not seen my first video on materialized views, I will highly recommend that you pause this video right now and go ahead and finish that video first. Guys, I have another request for you. If you have not subscribed to my channel, please go ahead and do it now so that you get a notification as soon as I upload a new video. Now before we discuss what we are going to learn in today's video tutorial, let's quickly go ahead and do a recap of what we discussed in our previous video. So in our previous video we discussed that materialized view are database object which actually stores the output of the query in a physical location, and that's the basic difference with views. Views are just the metadata, so every time you run a DML operation on a view, it's going to run the original underlying query of the view at that particular time. This actually arises an important question. When we are storing the data at a physical location, why don't we use a table instead of a materialized view? And there are multiple reasons for that. In order to populate a table, you have to write a process which again is costly, and there is a possibility that you may leave certain loopholes in that. That's one thing. But the most important part is the query rewrite functionality of materialized view, using which you can significantly improve the performance of your queries and reports without making any code change. Another advantage that we discussed of materialized views was when we are accessing data from a remote database, it can actually consume a lot of network bandwidth and it's very slow. So in that case, what we can do is we can create a materialized view in our local database, which is also known as snapshot from my remote database, and I can actually update that materialized view on a regular basis as per my business need. Then we also saw a situation where my underlying source master table of the view was updated, but my materialized view was still reflecting stale data, which is actually not good because my materialized view is giving me a false impression. So I need to actually refresh my materialized view on a regular basis. And what are the refresh strategy? There are 3 refresh strategies, and we are going to discuss these 3 refresh strategy in detail in today's tutorial. So 3 data refresh approaches are complete refresh, fast refresh, force refresh, and we are going to understand them in detail in this tutorial. What are the challenges with complete refresh? What are the prerequisites for fast refresh? What exactly is force refresh? And when actually we should conduct these refresh? We are going to discuss all these topics in today's tutorial. In complete refresh, our materialized view is truncated and loaded again. So when we are doing a complete refresh, it will truncate or delete the entire data of materialized view and reload it again. Now, though this sounds like a simple and effective approach, there are certain challenges with it. What are those challenges? This particular approach can be very time taking. Now assume you have created a materialized view where you have performed aggregation on tables that have billions of rows, and that particular query is going to take a lot of time. So the population of this particular materialized view can take a lot of bandwidth and time, which can be a problem in certain cases. The second challenge is redo and archive log that Oracle generates when it's doing this complete refresh. Now what does this mean? Since we are truncating and loading the materialized view, there is a possibility that our process may fail. In that case, Oracle wants to make sure that it can populate the earlier data again, so it creates all these redo and archive logs so that in case if our current refresh process fails, it can go ahead and repopulate that particular data. And trust me on this guys, if your refresh process takes a lot of time or your materialized view has a lot of data, these redo logs and archive logs can get really huge, which can be a performance problem for the entire database. Also, when we are rebuilding the entire view, that means we will run the entire underlying query again, and since we mentioned we have billions of rows, it can actually lead to significant IO usage, which again will increase my CPU utilization and it will impact my performance as well. If I have to quickly summarize in which case I should use my complete refresh, When my underlying query does not take too much time and my materialized view does not have too much data, in that case I will recommend going for complete refresh. So we saw there are certain challenges with complete refresh. What exactly is an alternate solution to that? And that solution is fast refresh. So here, instead of doing a truncate and load on my materialized view, we do a incremental refresh. But there is a prerequisite to incremental refresh. The Oracle should be able to tell what exactly has changed since the last refresh was done for this particular materialized view. And that particular prerequisite is being achieved by maintaining materialized view log or snapshot log. These logs contain the information that since the last refresh, what exactly has changed in my master table. So in order to execute fast refresh on a materialized view, I have to create a materialized view log on the master table of my underlying query. My materialized view log, it captures changes to the master table and it forms the basis for updates in my materialized view. So we discussed two approaches: complete refresh, which does truncate and load. The challenge with that is it can be very time taking and it can actually have an impact on my database performance as well. Then we talked about incremental refresh, where we actually maintain a materialized view log on my master table, which captures what exactly has changed since the last refresh, and it forms the basis for incremental refresh of my materialized view. What exactly is this force refresh? So in force refresh, first it will try to implement fast refresh using the incremental approach. But for some reason, if my materialized view log is corrupted or not accessible, in that case it will go ahead and implement the complete refresh. So force refresh is combination of fast refresh and complete refresh. If for some reason it is not able to perform the fast refresh, it will go ahead and perform the complete refresh. Now this actually is a very vital question. When should we go ahead and perform our refresh? So in my data warehouse, if I'm loading my fact tables as a part of nightly batch job and my materialized views are actually configured on those fact tables, I should update my materialized views once the data population in my fact table is complete. Or if my fact tables are populated multiple times during the day as a part of batch process, I can go ahead and update my materialized view once the fact tables have been updated. So here I am refreshing my materialized view on a periodic basis, be it as a part of a nightly cycle or during multiple times in a day, adhering to the update of my fact tables. If I have created my materialized view on a table that is changing very frequently, should I go for a periodic refresh or should I refresh my materialized view as soon as my source data has changed? Well, it actually entirely depends upon your project scenario. If you don't plan to access your materialized view till a particular time, I will recommend that don't refresh your materialized view every single time a commit is being performed. That's going to be too much work for Oracle. You can refresh the view when you actually anticipate that yes, after this my reports are going to run and they are going to use my materialized view. So now I should go ahead and schedule my materialized view refresh. But if you anticipate that your materialized view is going to be used throughout the day by users, I recommend that you go ahead and configure refresh on commit so that every time your materialized view goes ahead and gives you the correct picture. Can you think of a situation where you never want to refresh your materialized view, or you want to manually do that refresh but only once in a while? So there are certain list of value tables that actually don't change over a period of time. For example, the number of states in India, they usually stay stagnant, they are not going to change that often. In that case, you can specify or you can configure your materialized view as never refresh, and if you have to conduct that refresh, you can do it manually. In the next video, we will understand the syntax of materialized view and how we can actually go ahead and configure these options. We will see a couple of real project examples that will actually demonstrate the usage of these materialized views. We will talk about DML operations on materialized views and whether you should do them or not, and we will discuss in a little more detail what is the difference between a view and a materialized view. Hopefully by now you have a theoretical hang of what exactly is materialized views, what are their purpose in Oracle, what exactly is their basic difference with views, what is query rewrite, and what are the advantages that are being offered by materialized views. So thanks a lot guys for watching this particular video. I will see you in the next one.